Okay, so picking up where we left off on that last example, we want to know whether or not the blood and breath tests are mutually exclusive or disjoint. We also want to know whether or not they're independent. And as we saw in the previous example, we know that they can't be both. So if we know one, then we know that the other couldn't possibly be true. Part A should be pretty straightforward to answer. In order for the events to be disjoint, they would have to have no outcomes in common. So in this case, we would have to know that a suspect could not be given both tests. But since they specifically tell us that the probability of being given both tests is 22%, 22% of our suspects receive both tests, which means that it is definitely possible to receive both of those possible outcomes. So they're definitely not disjoint. So I would just say no. We know that 22% of all drunk drivers do receive both tests. So they are not disjoint. Now part B is just a little bit more complicated. We're going to go back to our test for independence. And again, the idea is if we know that one or a suspect has been given one test, does that make them more or less likely to receive the other test? And we could do this in any combination we want. So I'm just going to say that if we know the suspect has been given a blood test, are they more or less likely to also receive a breath test? So I'm going to look at the probability that they are given a breath test, given that we know that they received a blood test, versus just the probability of them getting a breath test. If those two probabilities are roughly the same, then knowing that the suspect got the blood test has no bearing on whether or not they got a breath test, meaning that they would be independent. But if they aren't the same, if this is more or less likely to occur, then we know that getting a blood test makes the breath test more or less likely to occur, and therefore they would be dependent. So going back to our formula, the probability of getting a breath test, given that they've been given a blood test, would be the probability of getting a breath and a blood test. Breath and blood. Divided by the probability of them just getting a blood test. And they've told us that 22% of our drunk drivers are given both. So the probability of getting both a breath and blood test is 0.22. We know that 36% are given a blood test, so the probability of getting a blood test is 0.36. So the probability of getting a breath test, given that you have received a blood test, is approximately 0.611. In other words, 61% of those who were given a blood test were also given a breath test. Well, they've also told us that the probability of just receiving a breath test is 78%, so 0.78. So 78% of our drunk drivers receive a breath test, but only 61.1% of those drivers who received a blood test were also given a breath test, which means that we are less likely to have a driver who receives a breath test if they've already had a blood test. We're more likely overall to get a breath test than if they have already had a blood test. So these two events cannot be independent of each other. So let's just write that out. These two tests are not independent. A suspect is less likely to be given a breath test given that they were given a blood test. So in this example, the events were neither disjoint nor independent of each other.